Okay, fine, guys. Today we'll discuss here ether channel. So, what does that mean by ether channel? So, what is the use case of ether channel? So, what are the requirements in real time for the ether channel? So, entire thing we'll discuss, and what are the requirements for once we if you want to configure as a ether channel, what are the major requirements? What we need? Which kind of physical connectivity we need? So that thing we'll discuss. First of all, we'll discuss what is ether channel. So as we discussed earlier, we do have a LAN network. We'll use ether connectivities, ether, ether port connectivities or ether cable connectivities. In between switches are in between users are in between L3 devices to L2 devices. We'll use. So here we have some requirements like so the connectivity it is there in between switches. Here we have a switch one and its access switch you can assume like it's a core switch or a distribution switch, whichever the switch. But this switch is connected some multiple users. So here we have a multiple users. So so what is networking in between? Communication of different users through using the using here any networking device. So here we are using the switch as a networking device. Through this networking device, we can communicate at one floor to another floor or one geographical location to another geographical location, one branch to other branch. Can assume anything. So we need the connectivity in between devices. So everything is working fine. So this PC or this user one is communicating to this user. Here we have a user, the user two and user three and user four and user five, user six. So communication happen whichever the in LAN segment is in switches mainly work within a subnet. So every connectivity is working fine. So this user based on the MAC addresses can reach the second floor whichever the users. We can easily communicate with the based on the MAC addresses. So some connectivity failed. Single point of failure means single point of failure means here this connectivity is gone. The cable connectivity is gone. The cable connectivity is gone. So still they can communicate or not. If connectivity is gone, still they can able to communicate or not.
No.
No, right? Good. So what we need for that? What we need now? We need a multiple physical connectivities. Okay. I'll use one more thing, one more cable here. I have used more cable. If this link is gone also, we have a redundancy. Yes, we can able to communicate. But in this case, in this picture, STP will be participate. STP will become. In this scenario, STP will come. So here we have a FA 0 by 0, you can assume, and FA 0 by 1, and here 0 by 0, and here 0 by 1. Okay. The connectivity is there. So here this connectivity gone means the it will be DC port and this one is the active port, root port. This is a designated port DP and this one is RP, root port. Everything is working fine and STP also working fine. So when STP come picture, if though those two ports are working fine, so one port will be automatically STP will block. STP only it will be blocked. So otherwise, the loop will be originated. Switches broadcast the information, right? So switches broadcasting the information means whichever the information he originated, switch, this port will be received,
Etherchannel.
and this port will be again received, and this ports also receive. So here loop will be occurred in STP. So for that, that loop we are avoiding through STP. So automatically by default STP is running in switches. That thing we know already we discussed. Now, but in this case, if STPs came to picture, STP is blocking one port. Here also some problem is there because here we if we have multiple ports, so these many ports, we have four ports. In that port, only one port will work. Apart from that, all the ports are will block. If you want to check, so I'll show you in lab also. I'll take here two switches quickly. I'll take two switches and I'll take here four connectivities, four connecting cable, physical cable. So here you can check. So check. The HTTP is working now. So you can check the show commands. Enable show spanning tree. So here learning state still shows spanning tree. So here root bridge will be elected after then root designated ports and root port will be elected. Election will be originated. And here now forwarding port came. So now here you can check one port only active. Apart from that, here this is the root bridge and this is the non-root switch. So here you can check only one port is green color. Apart from that, three ports are amber color. So this means they are amber means they are ready to come. When the port go, this port will be went down. One if in case the switch port of this port will be went down, then amber color will be green. So that port will be active port. So here to tell me, we are losing our whichever our organizations connectivity or amount, whichever the physical connectivity they spend for amount for this also, but we cannot using properly. We cannot load balancing it. So by here we are using only one cable. So now you tell me it is a good architecture or not. We are not utilizing our resources. So these all are the blocking states. Fast Ethernet 0 by 2, 0 by 4, 0 by 3. These all are the blocking ports. So for that, it is not a good architecture. I hope. If you understand means this is not a good architecture. So what we'll do now? I want to utilize my full resources. I should have to use my full resources. So here what I'll do now, I'll utilize entire connectivities. So I'll make it as a one port. This is the logically looking like four connectivities. Logically four. Sorry. Physically four. Physically one, two, three, and four. Physically here connectivities are four. What I will do, I'll use ether channel. Ether channel. So it's a kind of protocol. It is kind of service, ether channel service. So based on this ether channel, what I will do, I'll make it as a logically one port. Logically, I'll do one port. Logically, I'll do one. So physically here, multiple connectivity. If you have eight also, one more four also. So those four, I'll make it again. These are all the things I can use only one. So successfully, I can utilize my resources. That time you can see here all the green ports only, not this amber colors. All are the green color only. All ports it will look like green color only. All the ports like green color only, not amber colors. So likewise here, whichever you are seeing, likewise you can see here also. So what does it mean? Ether channel. It is a use to aggregate multiple physical links. Here we have multiple physical links, 8 minimum and up to 16 to 16 we can make it up to 16 connectivity, 16 cables. 16 cable, we can make it as a one logical link. One logical link. That time we can utilize our full bandwidth also. You can check here. Basically, interface fast Ethernet. So interface fast Ethernet 0.1. So here you can check how much Mbps its a speed is 100 Mbps is there. If I'll make it as a ether channel, that time this will be 400. It will be look like 400. So the logical port is look like that time it will be we can see here to 400 speed. We can use our entire resources, and here we have some load balancing process also. So step by step we'll discuss. So first of all, what is ether channel? So ether channel, it is a process. It will be aggregate multiple physical link into a one logical link. These are the multiple physical link we can aggregate, and that will create as a one logical link. That logical link we call it as a port channel actually. Whichever it's a port only. We have successfully were created one port. So these are the ports, right? So we aggregated like one port. Logically, it will be one port. This process we call it as a ether channel process. So we'll discuss step by step now. Any doubt? The requirement of ether channel and how it will be we can create. I'll show you step by step. So ether channel we're discussing here. So it is used to aggregate multiple physical links into a logical link through which we can get higher bandwidth. Just now I have shown here. So here we have a 100 Mbps. If I have this kind of four cables means that will be 100 plus 100 plus 100 plus 100. It means 400. So it will be look like we can increase our bandwidth also and reduce as well as we can reduce our whichever the we are reducing our latency or whichever the process. So if one port also goes down, so no issue on that. So this logical link will be called as a ether channel. So here multiple physical link into a one logical link. Multiple we can aggregate multiple physical link into a one logical link. That link is called as a ether channel. So we can use this concept on Cisco devices as well as non-Cisco also. It is kind of open standard protocol, likewise you can assume. So we can use this process. So Cisco also and non-Cisco also. Cisco devices like whichever we are using ISR 4431. These are the routers, and 4431, 4451, 4461. Those are the routers, and where also. And apart from that, in here you can check that these are the Cisco devices. Cisco switches models are here available. So these are the models 3560 and 3650 and 29. These are the 2960. These are the series of switches. We here also we can utilize it. So in HP, Aruba, Palo Alto, those are the having the different switches, and where also we can use this concept. And we can aggregate maximum 8 and 16, up to 16 physical links, up to physical link as we discussed here. So these are the only four is there. Up to 16 also no issue. You can utilize it. We can aggregate it. So after enabling ether channel, once you enable ether channel, so I'll discuss something more here. So for STP, so here the STP will work. How it will be work? So yeah, I have taken one more switch, and those switches are connected like here we have connected like four ports. I assume These are the four ports. And here one more four ports are there. So this port and this port channel I have created. PO1 look like this. PO1 port channel 1 and port channel 1. Here we have one more port channel, PO2 and PO2. So how STP will work now? So this is, if you can assume, it's a root bridge, root switch. It's a root switch, and it's a non-root switch. It's a non-root switch. So now you can tell me, if this is a root switch, it means it's a DP and one more DP. This is also DP port, designated port. It will be forward the packets. It will be forward the frames, and it will forward the BPD, superior BPD use, Bridge Protocol Data Units. One more is also port 2. So DP opposite, if this is a port 1 and port 2, it means then it will be elected as a root port. Based on the port, it will be elected as a RP, root port. So it will be automatically, it will be moved to the blocking port, alternate port. So based on the ether port numbers, ether channel port numbers, it will work. It is kind of a one interface only. It is kind of one logical interface. This is a one logical interface, and this one is a one logical interface. Here also STP will work. If you don't want, then use likewise. So simply switch is there and one more switch. In real cases, real time will use likewise only. Will not use proper on this kind of scenario. Will use this kind of scenarios only. This is a port 1. This is a port 2. STP will work, but based on the all the ports. This is a port 1 and port 1 only. So here designated port DP and here RP always. No blocking port is there because it's a single kind of logical port. So successfully we can use our all the ports. So here for this some requirements also we need. So for that, so STP will work process is same. So based on the logical port, it will work. Okay, everything is good. So some requirement is there for ether channel. For requirement means speed must match. So speed means whichever the bandwidth we are using here, those should be same. Those should be same. If you are changing some delay or some bandwidth, that time we cannot able to configure. Here we have, see, so here two switches and two switches. This is a fast Ethernet 0 by 0, and you have changed some delay, something delay or bandwidth you changed. So by default bandwidth is 1 lakh. You change it like 90,000 or 50,000. So 50,000 means it will be 40 50 Mbps. So here 100 Mbps by default. So speed is not matching. So ether channel will be not formed in these cases. So duplex also. If duplex also mismatch, you here you configure as a half duplex, and here you configure as a full duplex. By default, full duplex only, auto mode only. You change it some reasons. So that time also it will be not form the ether channel. So whichever the ether channel, here we have a some standard modes. Statically we'll configure. I'll discuss standard mode. Here we have a some, we'll use on and desirable and active. Those are the modes are there. So two types of ether channel, basically static and dynamic. Before that, here the mode whichever you are configuring, both side it will be must match. If one side you configure as a on, other side you configure as a desirable, so also ether channel will not form. And Encapsulation method, we have a dot one queue. You configure here dot one queue trunk port, and you configure here ISL. So that time also ether channel will not form. And VLANs, whichever the VLAN trunk VLANs, you allowed something here. You allowed VLANs something 10, and here 20, something you allowed. But here you allowed 30 and 40. That time also it will not form the trunking, not form the ether channel. So here you configure native VLAN. Means native VLAN means whenever the data is transferring this side to another side. So dot one queue, we have a native VLAN, that is one by default native VLAN one. So dot one queue, what it will be do whenever the packet is transferring, that time it will be remove the tag. It will be empty tag. That time based on the native VLAN, it will be move the forward the packet. That
So
time,
we can't hear you.
uh, if native VLAN is mismatched, that time also it will be not from the ether channel.
Can you say again
These are the
because your voice
requirements
was
we have.
breaking?
Hello,
Please go through with the requirements once again. Your voice is breaking. We can't hear.
fine. Okay. So here we have some requirements. Here you can check. So speed, whichever the speed we have, we discussed 100 Mbps, and if you configure as a 50 Mbps, other side, that time also it will be not from the ether channel. And duplex also, half duplex and full duplex, that should be matched. If you configure full duplex means both end, by default full duplex it is there. That time also, if one side is half duplex, another side is full duplex, that time also ether channel will be not formed. And ether channel standard must match. One side is on and another side is off. So here we have some modes. I'll show you. Just I'm showing you. So here we have modes, some modes where you can check active and auto and desirable and on and passive. So these are the modes we have. These are the standards. I'll explain very well. Just I'm showing you this mode, whichever you are configuring one end, that should be matched. If you are configuring PAGP, another end also PAGP, you should also connect it. One end you are configuring LACP, another also you should have to configure LACP. One side you configure as a static mode, another side you should have to configure statically only. So this thing I will discuss later on. And trunk encapsulation. One side you configure as a dot one queue, another side you configure as a ASL. Then also it won't form. So encapsulation method also must match. And trunk allowed VLAN. So here native VLAN is there. So whichever the native VLAN or native VLAN or allowed VLAN, it means we have a allowed VLAN some keyword, whichever you are allowing the VLAN trunking. So that should be matched. Interface pass Ethernet 0 by 1 and switch port trunk. So allowed VLAN. If you are allowing here VLAN something 10 and 20 and 40, likewise you are allowing. So another end also same VLAN you should have to allow. That time only the ether channel will be formed. Allowed VLAN also must match. And native VLAN means the whenever you enable as a encapsulation method dot one queue, that time native VLAN one is by default there. That time what it will be happen whenever the packet is transferring. So here source to destination, the tag will be removed. The tag, who will be responsible? Native VLAN will be responsible for the adding and removing the tag. Native VLAN will be responsible. So that if you change the native VLAN like something one instead of you configure as a 10. So native VLAN both and 1010. If you configure here 10 and here 20 means native VLAN, so it won't match. If it is not matching means ether channel also not found. So make sure whenever you are configuring ether channel, this is the requirement. So then only you can form the neighbors. Then only then ether channel will be formed. Okay, understood? So here for ether channel, we have some load balancing algorithms. So here we have a load balancing algorithm also. Source MAC address, destination MAC address, source and destination MAC address. These are the MAC addresses and these are the IP addresses and these are the port numbers. It will based on the MAC address, it will be transfer the data. Based on the IP address, it will be transfer the data and based on the port number. So what does it mean by here? So here we configure ether channel in between switches. So here we have a user. So here we have one user and another user is here. And this is user one and user two. User one wants to communicate user two. So here ether channel you configured. So that time here S0 by 0 having some port. For example, the port is 001. So 001 port is MAC address is this port MAC address is 001. So it will be transfer data that port. So one more user is there and it's a source MAC address based on this user FA 0 by 1 and this port having MAC address is here. This port having MAC address is 002. Then transferring the data at this port. So if we have likewise 4, 5, 6 in something, so this port based on the MAC address. So this is a source MAC address and this is a destination MAC address. This is the destination MAC address. So based on the destination MAC address, based on the source MAC address, it will be load balancing the information. So based by default, it will say use only one physical connectivity. It will be not use some packet transferring this physical connectivity, some packets are transferring this physical connectivity, some packets are transferring this physical connectivity. Not likewise. User information, they will load balancer. They will load balancer the this user different physical connectivity. This user different physical connectivity. This user three different physical connectivity. That is based on the source MAC address. 001 means first come first out. 002 means first later on come later out. So likewise 003 it will be moved 003 004 then it will be moved. After then again one more user is there 5. Again it will be moved this port only 001 because here we have a poor connectivity. Once one is down, then it will be moved to the one is down. One port is some physical connectivity is gone. So we have a three ports only active now. So that time it will be used three ports only. So guys, here we are using like free of Zoom meeting. So 10 minutes only is there. Once the session will be ended, though, so rejoin the same session, same link. Rejoin the
Okay.
same link. Only 10 minutes is left. Don't forget to join. So I'll not tell again. So here we based on the destination port number also it will be allowed. So these are the load balancing methods we have. So these are the load balancing methods. You can read it. And types of channel here we can configure types of channels. So static and dynamic, two types of. Here we have a two types of. So first one is ether channel. We can configure statically. Other one is dynamically. Again, dynamically we have a two types again. Statically and dynamically. Dynamically we have a two modes again. Two types. So one is PAGP. Other one is LACP. LACP. So two types method we have. Ether channel means here ether channel we can configure as a statically also and dynamically also. Ether channel will form dynamically also. We can configure manually also. So statically here you can check is hard coded. So manually we are configuring, right? So manually we are configuring the port to be part of ether channel. We are part of ether channel. We are manually configuring. But in this case, switch will never know if the other end of the ether channel goes down and this might cause loop. So this whenever you are configuring statically, if the other end port, neighbor port, here we have two switches, so ether channel farm. So these ports are down. This switch don't know the reason which kind of loop occurred. So this the problem is there. So here we have a mode is on. Just I have shown here. We have a different modes in ether channel. Here I have shown. So again, channel group, anything you can take, and mode. Here you can check. Here you can check on. On is there. Ether channel statically we are configuring. That is the mode name is on. So we can aggregate maximum 8 links, maximum up to 8 links, and mode will be on. Here, mode will be on. So now move to the dynamically. Dynamically, we have, as we discussed, one is PAGP and another one is LACP. PAGP, port aggregation protocol. Port aggregation protocol. And PAGP stands for Port Aggregation Protocol, and it's a Cisco proprietary. Again, the Cisco proprietary. In Cisco devices only it will be formed. We can aggregate maximum 8 links, number of links. In case of PAGP, there is two types of modes, and here we have two types of mode. Mode is desirable. Other one is auto. Two types of mode is there. One is desirable, another one is auto. So here you can check. So here you can check PAGP having two modes. PAGP having two modes. One is auto, another one is desirable. So auto is formed actively, it will be formed. Both end is desirable also is there. Then also it will be formed. One end is auto, another end also auto. Then it will be not from the Isha channel. One end is auto, one end is desirable. Then also it will be formed. Same likewise, DTP what we configured, same likewise here also it will be formed. And there we have a dynamic desirable, dynamic auto, right? So dynamic auto mode is there. Then we cannot propagate the trunking. So DTP, dynamic trunking protocols. Here also same thing, it will be formed, desirable. So one more method is LACP. LACP stands for Link Aggregation Control Protocol. It is open standard again. It is an open standard mode. So in every device we can use this service. We can aggregate maximum 16 ports. Here we have 8 only. Here we have maximum 16 number of link in case of LACP. But the case here we have some restrictions is there. 8 links will be active. Apart from that, 8 other links are standby. If you are configuring Ether channel in between switches, these are the eight. Let's assume these are the 8 links, and one more 8 links here. Only one port channel will be active. Other port channel will be standby. If this port channel is goes down some restrictions,
Reem, your
some
voice is
conditions.
still breaking. We are not able to hear you.
Sorry guys. Okay, some internet issue maybe. So this
Uh,
is a port
Reem,
channel.
your voice is breaking. We are not able to hear you.
Okay, okay. Now it's visible. Now it's listened properly or not? Still is going on issue.
Still same issue.
Liam, we can't hear you, Liam.
I'm not speaking anything. Now
Okay.
Okay. So here LACP will quickly discuss. LACP having two modes again, active mode and passive mode. Active mode means uh, actively it will be farm the neighbors, farm the ether channel. You can check here active mode and passive. Active mode is both an active is there, then it will be farm. One is passive, another one is also passive. It won't farm. So no, it will be not farm. You can check here. Both an active is there, then farm. So here this desirable means it will be farm. Desirable, one end also desirable, another end also desirable. Yes, we can farm. One end is desirable, another end is auto, then also farm. Both end auto is there. It will be not farm here. No, it will be not farm actually. Some mistakes is there. It will be no. So one is active, another is passive. So it will be farm. One is active, another is passive. Yes, farm here. Some mistakes are there. So anyway, here active both and it will be farm. Active passive is there. Ether channel will be farm and desirable and auto mode is there. It will be farm and auto is there. Not it will be not farm. So in lab we'll discuss more. So if you have any questions in ether channel in this section, if you have any questions, ask me. Otherwise, we'll start the lab in this ether channel. So mostly in ether channel, multiple physical links with aggregating. We are aggregating like one logical link. So the simple scenario, multiple physical link, we are aggregating as a one logical link. We are creating as a one logical link. That is what ether channel. So for that, some requirements are there. Speed must match duplex and ether channel and trunk encapsulation, trunk allowed VLAN and native VLAN. So these are the requirements we have. Apart from that, and ether channel, some algorithms are there. So these are the algorithms we have, and two types of methods we have. First one is static, another one is dynamic. So mostly we'll configuring the dynamic methods only. In that also, if you are using Cisco proprietary, that time you will use PAGP only. PAGP, and there we have a two modes, that is desirable, and one is a active. So two modes we have. So one is desirable and active, and sorry, auto. So guys, rejoin the session. We'll discuss more. So another one is LACP, link aggregation. So everyone rejoin the session.